Yeah, we'll come back to this. All right. So from either the start page or the start menu, we select schedule task, and there's a couple different subcategories here. So let's first talk about discovery and benchmark tasks, beginning with discovery. So a scheduled discovery task is exactly what it sounds like. We pick a frequency. There's all different scheduling options available. We choose, we can mess with the network settings here if we need to, the shared network settings. And then for the discovery settings, discover all live network is to perform a seed discovery, neighbor walking, using all current member devices as our seed population. So, and then discover selected is just put in parameters like we saw before, whatever they might be. And then API triggered discovery is well outside the scope of this class. So if we want to verify that NetBrain can still talk to stuff and that all our credentials and so forth are still accurate and that devices are still there, we could perform what's called a tuning operation. Tuning is, as I think I said before, NetBrain speak for can we still talk to this thing? Now there's two different methods of tuning, two different modes. There's verify tuning, which means just check and then say yes or no. And then there's auto set tuning, which is check and fix. In other words, if let's say all of a sudden we can't talk to the device via SNMP, we're going to go back to our list of SNMP strings, and it's going to go down the list trying each one in turn until it finds one that works. And if it does, it's going to say, okay, now we're going to use this community string for this particular device instead of this other one. So check and fix. Now, rediscovering an existing device is exactly the same thing as performing an auto set tune. And I'll show you how to do manual tuning without using a discovery task as well. Actually, let's do that now before I forget. So what we do in domain management, we go to the start menu and we go to tune live access. And this lists all of the devices. So it's only going to show us the first 100 by default, but if we select a line here and just keep holding down end on our keyboard, it'll keep bumping to the bottom of the table. And then this is how we get it to show everything. So you may need to do that a fair bit if you want. We can again mess with our settings, and then under options here, we can choose what are we going to check, and then verify versus auto set. So a verify check is actually very quick, as we'll see here, because it is, of course, multi-threading, although to what extent depends on your precise version, and of course how many front servers you've got going on. So you can see this particular environment. If you're seeing something like this, this is a disaster area in terms of device access. Just to give you some context, this is an absolute disaster area. You should be seeing success across the board. But, it's a test environment. So anyway. All right. So that's how we do it manually. But if we want to set up a regular auto set tune, the way that we do that is as a scheduled discovery task. And the settings specifically is we say discover all live network, and we set the discovery depth to 0. And in so doing, we're not going to try and find anything new, but we're going to rediscover everything that already exists. So I didn't really fully explain discovery depth. I did say it's the number of degrees of association away from the seed devices. So 0 is just the seeds. Depth of 1 is the seeds and their neighbors, but no further. 2 is neighbors of neighbors, and so forth. So just to make that absolutely clear. We're not going to worry about plugins. And then do we want to be alerted if there's any difficulties with the discovery task? And then we have this go off on a regular basis. Essentially, as soon as it's feasible, we want to have an administrator come in and check the fine tune to see if there's anything that's wrong here. So there's that. And then as far as pulling detailed data and so forth, that's the realm of a scheduled discovery task, or excuse me, a scheduled benchmark. So again, whatever frequency, And when we're talking about benchmarks, we can have as many different benchmark tasks as we want, each one on its own schedule and with its own, each one on its own schedule and with its own settings. So if you want to have, for example, one benchmark that goes off frequently and only captures the most key data, and then a less frequent one that's going to capture the less frequently changing data, or anything like that, divide up by, regions around the world. So different regions are captured, their data is captured at different times during the day. All that sort of thing can be very common. So, and then what scope are we what range of devices are we looking at? So for traditional devices, it's everything by device group or by site. For API servers, we're selecting by server. And remember, selecting a controller is selecting everything that it is controlling. Retrieve live data. This is the built-in data types that we talked about briefly in NetBrain 101. So this first built-in live data category, this is stuff that NetBrain is going to use it directly in the either for just basic device data, or it's going to use in the calculation of the topology, or both. So all of this should really be pulled on a regular basis from all devices to let NetBrain operate properly. NCT table, these are also built-in data types in that it's included in the basic drivers for the device type as to how to retrieve any and all of this that is actually relevant. So my general feeling as far as this sort of data is better to have it and not need it than need it and not have it, but the system's not going to use it directly in its calculations. It's just a nice thing to be able to snapshot and hold ready for the end users to use for comparison or just viewing or whatever. So what you pull and to how often is entirely up to you. And then below that, there's a category for each type of API-based system that is supported. And so if I'm pulling from, say, Cisco ACI per the device scope, I should really make sure that I'm telling it to pull ACI data from those devices. Otherwise, there's no point in including it. And then you can put a kill timer on this particular step of the process. And this is nice to make sure that things don't get hung up. So for example, just a general rule of 6 or 8 hours is usually recommended, unless you know for a fact it's going to take longer, and that's fine. But just putting something with a generous time limit is generally a good idea. Next, CLI show commands. Here we can specify certain show commands to be executed against all devices of a particular type or types. And then this is just going to pull the raw output and store it. So this would be good for delta comparison, say in Smart CLI or something like that for building history. But if we want to both pull the raw show command and snapshot the values of individual variables, there's a different way to do that, a better way usually. And that's a DVT parser task that we'll talk about in a bit. Additional operations. So here we can, first of all, do we want to recalculate the membership of our cloud objects and their virtual route tables are similar. So if we have any of these going, recalculating them after pulling data is definitely a good idea. Do we want to recalculate the similar virtual route tables that can be generated for AWS, Azure, or G-Cloud environments? Any of these we have going on? Very good idea. Do we want to rebuild our calculated topologies for any and all of these possible topology layers? Generally speaking, we want to rebuild this once a day at least. So if we have, let's say, one thing that's actually fairly standard in large-scale enterprise networks is to actually have a minimum of 3 system benchmarks, one targeting NALA, one targeting EMEA, one targeting APAC, but only one of those 3, usually the one that's in the going off in the region where the company is headquartered, only one of those 3 is actually going to have these additional operations enabled. The others will just be pulling the data for their specific area of the network, because all this is based on whatever the most recent set of data is for a particular thing. It doesn't matter exactly when it was gathered, and it certainly doesn't matter whether it was gathered as part of this particular benchmark. Next, we want to recalculate the membership of our dynamically defined device groups, sites, generally a good idea. Do we want to rebuild our default data view? This is the basic information that's shown on every dynamic map by default. So keeping that up to date is, I think it's usually a good idea, but it's up to you. Calculate pre-qualification. This means to determine which data view templates are, I think it's data view templates, possibly some QApps as well, but it's mostly DVTs. Which ones are relevant to which devices in the environment. And this is going to affect, if we have a dynamic map, come on, honey. This is going to affect in the data view tab which data view templates actually show up as suggestions here. It's going to be the ones that either haven't been qualified, indicated by this tiny little white and orange circle, if you can see it, or ones that seem to be relevant, have been pre-qualified to at least one of the devices on the current dynamic map. So generally a good idea. Rebuilding the network tree, the system hashtags, and these visual space templates, all this is stuff that's going to be going to show up for the most part in the network tab here. So to take the visual space templates as an example for different technologies, for say Cisco ACI, it'll try to create a hierarchy based on the applications in the ACI, the fabric, the tenants, and then in each case, it's going to try and generate some dynamic maps to be useful to us. What does the underlay look like? What does the overlay look like? Things like that. So it can be incredibly powerful if you, for anybody administering, in this case, say a Cisco ACI environment. And it'll do this for a lot of other techs that we support as well.